Hello, welcome back to Daily LeetCode Live, where I do LeetCode Daily questions, raw and uncut. So let's get started. So today's question is a medium after 5 easy from the past 5 days. Yeah, so the question today is tuple with the same product. So given an array nums of distinct positive integers, so the integers are distinct and positive, remember that. Return the number of tuples, so tuples of 4 numbers, such that a times b is equal to c times d, and a is not equal to, so and a, b, c, d are not equal. So we only want to return the number of tuples, right? So how many numbers do we have? Well, we have 1,000, so that means a n squared solution would work. So my first thought, well, we can just get all the possible products from every pair, so that will take n squared, and then we can just kind of have a counter, and we just do a bit more arithmetic to figure out like what works and what doesn't. And yeah, I think something like that will just work. Actually, why are there so many? So the only so like what I'm thinking right now is that if we like if we have a set instead of a tuple, well, we can only really make one set that has that property, right? So let's say like a times b equals c times d. If we are like basically saying that how many sets can form these, well, for this it will only be one, but then we have 8 here. So why is that? Well, so the first thing is you can swap a and b. The second, you can swap c and d, and you can also swap the left hand side and the right hand side. So just look at the example case here. It does seem like here we get 2 different sets of possible like sets of 4 integers. So we have like 1, 2, 5, 10. We can do like 1, 10 and 2, 5. The other would be 2, 4, 5, 10. So 2, 10 and 4, 5. But then we have 16 here. So like just by looking at the examples, it kind of tells me that whenever we find a set, we should multiply it by 8. So let's see why it is tied to 8. So let's have AB equals CD here. So the first possibility is that we can swap these two. So we can swap left hand side and right hand side. So that would create twice as much possible tuples. So well, multiply by 2. And then we can swap B and A. So swapping B and A would give us another 2 times, like another twice as much like possibilities. And then well, same for CD. So I think this is where the 8 comes from. Yeah. So when I say swap, what I mean is like if we treat AB as one thing and CD as one thing, so let's say like left is equal to right. Well, first of all, we have the option to swap left and right. Second, we can have 2 different forms of left hand side. So we can have AB, or we can have BA. We can have CD here or DC here. So it's basically like we have 3 different things that have two choices. So that's where the 8 comes from. Yeah. So now the last question is, how are we going to count how many sets we have here? So, well, I did say that my first thought is well, just multiplying like all of the pairs, and we see how many like how many of the same pairs are there. So so like the first edge case that I kind of think of is what happens, like the first example let's say for the first example, if we calculate all the pairs, well, we will get um we will get 6, 8, 12, 12, 18, and 24. So that's kind of the stuff we will get, right? But my concern is what happens, like, would there ever be a possibility where we have two different pairs that form the same product, but there are some numbers overlapped? Well, that couldn't be possible. Firstly, because the whole nums array is distinct, and secondly, if we do have one number overlap, so let's say like AB equals BC, well, what that means is A is equal to C. But we are guaranteed that all the numbers are distinct, so that means they have to be the same element, and therefore we are never double counting anything. So yeah, the last thing is we just have to work out like after we get this counter, how are we going to count how many sets are there? So well, by like just look at the base case. So if we have a product that only appears once, so let's say something like 6, well, we can only form one side of the equation for like the AB equals CD thing. We can only form one side, so it will never be possible. So what happens when we have 2? So if we have 2 like this, well, we can form one set, right? Like one big set here. So what if we have 3? If we have 3, so let's say we have like X, Y, Z, like these are all products. So these are all products, and they are all equal. Well, we can form XY, we can form XZ, and we can form YZ. What if we have 4? Well, WX, well, we can form this many, right? Like, we can form 6 here. So, like, just by looking at a few base case, it kind of makes sense that this is equal, like, to the arithmetic sequence. Basically, so when you only have 2 of these equal, it will be 1. If you have 3, it will be, well, 1 plus 2. If you have 4, it will be 1 plus 2 plus 3. And well, there's a well-known formula for this, which is just n times n minus 1 divided by 2 is equal to 1 plus 2 plus 3 plus all the way to n. So now that we have this in mind, we can just easily solve this now, I think. Yeah. Yeah, so let's get coding. So first of all, I think we need a counter. Yeah. Actually, a normal dictionary would just work perfectly. Maybe we can use a default date, which is a bit cleaner. So from collections, import default date. If I'm not wrong, default date is all lower caps. I might be wrong though, and I'll just search it up if I'm wrong on that. So we have a product store, default date int. Well, we want all the pairs to be initialized with 0. So like when we see a product of 6, if it doesn't exist in the dictionary, then we still want to do like the plus equals 1. We still want to increment it, right? So using default dict means that we don't have to initialize it, and then like we don't have to initialize it as 1 basically. It's just a bit cleaner, but dictionary would work just fine. Yeah. So we want to get the product for every pair. So range, actually, we do want to get the length of nums. So range n for j in range, I plus 1, all the way up to n. So that will get all pairs without the swap. So like it will get 1, 2. Like it will get like index 1, index 2, but it wouldn't get index 2, index 1, like the other way. So we are avoiding doubling, like with the I plus 1 up to n here. So all we have to do right now, we just do product store, and well, actually, yeah, so all the numbers are 10,000 or below. So we are guaranteed to not have like really big integers. Well, it doesn't really matter on Python because Python numbers are boundless. But it's just something like to bear in mind. So we can just do nums I times nums j plus equals 1. And after that, we are going to have number of sets. So we want to start with number of sets first, and then we can multiply that by 8 to get the number of tuples. Right. So we want to loop through the whole dictionary. So we have well, we don't really need to know what the product is. We just need to know the frequency. Just call count in product store. Well, actually, if we don't need that, we can just do dot values. So that wouldn't get the keys. It will only loop through all the values of product store. We basically want to do numsets plus equals. Well, we can think about the formula. So when we have 1, we should have nothing, right? But when we have yeah, so this is the formula I'm talking about. So if our frequency is 1, well, we want nothing here. If our frequency is 2, we want 1. Frequency is 3, we want 1 plus 2. So what does that mean? We want to use this formula, but then it should be the frequency minus 1. Like we should set n equals frequency minus 1 instead. So even when we get 2, oh, I made a mistake. It should be n plus 1 here. Yeah. Yeah, I was just thinking why is 2 giving 0 on this formula, but yeah. Yeah, this is correct. Like we can just set n equals frequency minus 1 based on the pattern we see here. So what we want to do is we just want to code up, so count minus 1 times count divided by 2. So we just want to do that. Well, we can check if the count is 1, this will be 0. If the count is 2, well, this is going to be 1. 3, it'll be 3. Yeah, so that works. And then at the end, we just want to return the number of sets times 8. So returning number of tuples. And yeah, that should work unless default dict is not right. Okay, default dict is right. Well, am I missing any edge cases? Let's see. I did not miss any edge cases. And there we go. We solved today's problem. I'll see you tomorrow. Bye.